What about this? This is where it gets tricky. Okay, here's an exception. You might want to say that you count everything up there and you say 1, 2, 3, 4, 5, 6, 7 sig figs. But that's not true. It's not the case. Okay? Because realize what these zeros are actually doing. They are not part of the actual number by mathematical definition. What they are what's called placeholders. They are taking up space until the actual number starts. Make sense? You've got the tens and the hundreds place. We want this number to start in the thousandths place. So we're going to take up space and fill in with zeros until that number starts. Now, if there was a 1 in front of this 0, then we have to count all those because we'd have zeros sandwiched in between, right? In this case, you start with zeros, nothing happens, you don't start counting anything until you hit a number, okay? Then you count after that. All right, so in this case, you've got 4 significant figures, okay? Here's it expressed in scientific notation. When we express something in scientific notation, we're looking for the sig figs right here, not here. This is just a factor that tells us what to multiply by. You're looking for your significant figures expressed in this decimal number, okay? All right, and here's the hardest one of all. So if you've handled it so far, then you're in good shape. Here's the hardest one we have. Some numbers are, in chemistry, what we call ambiguous. It's hard to tell what they mean. For example, if you give me the number 150, don't do that. Okay? I'll try not to give it to you, and you don't give it to me. I want decimal points, if at all possible, in all of your numbers that you give me. Because here's why. Take a look at this. 150. If I look at it the way that it is, ignore everything else that's there. If I look at the number 150 and I ask you, as written, how many significant figures do you see? What would you say? You would want to say 3, probably. Because of what I just said about the decimal and how you add zeros after, that kind of thing. But that's not true. Think about why. What did I call these zeros? Placeholders. Guess what this 0 is? It's actually a placeholder. As long as there's no decimal there, that's a placeholder. That's filling in the spot of the 1 spot so that the 10 spot can make it a 5 and then the 100 spot can go to 100. Okay? This is why it's ambiguous. If you just have 150 and I ask you how many sig figs in it, just as is, there's only 2. Because that 0 is actually a placeholder. It's not part. It's very ambiguous. We don't know how that 150 got there. If I ask you where did this come from, it could be a measurement that you had that was 149.5. You could have rounded up between 100 and 200. Who knows how you got there? It could have been 154 and you rounded down. It's nowhere clear enough to me. Your window is not clear. Because look, for example, if you want this to express, if this was exactly 150, okay, and it was on the dot, exactly 150, don't write it like this. Write it according to how many sig figs you want it to be, okay, if it's a perfect number. For example, if you want it to have 2 sig figs, write it like this. This is why scientific notation becomes so important. It gets rid of all this ambiguity that we don't know how many sig figs are there in this case. So 1.5 times 10 to the second, well, you know that would be 150, but the way it's written like this, there's 2 significant figures. If you take the same number, you could actually write this same number as having 3 significant figures. If you do this, 1.50 times 10 to the second. Move it over, 1, 2, 150. So it's ambiguous. You don't know which one it means. Avoid it. Okay? Use scientific notation. That's the easiest way to avoid it. There's sometimes people would, in the old school science, would put like a dot after the 150 to say that there's 3 significant figures there, but you won't see that from me. Don't worry about it. Does that make sense? Do I need to re-explain any of this? Are you with me? Do what either way? Yeah, it depends on how many significant figures you have to use according to your problem. That's what the next part is I'm going to talk about. Okay? Okay, now, exact numbers. Like, for example, if I say there are 7 days in a week, 7 is an exact number. Okay? Or if I say that there were 7 pennies in that pile, that was an exact number. What that means is they have an unlimited amount of significant figures because it's a perfect number. It doesn't get rounded off anywhere. It's not measured anywhere. So you could say 7.0 infinity. Okay, so It'll never affect the certainty of your measurements. That's what the point of this is. So any number whose value is known with complete certainty and is an exact number, you don't have to worry about its sig figs. Okay? It's not going to affect anything. For example, 1 centimeter. How do you define 1 centimeter? Well, centa means 1/100th of something. Okay? So a centimeter is 1/100th of a meter. That's its definition. You could put infinite amounts of zeros after the end of that, and it's not going to matter, because that's how it's defined. Okay? It's not a measurement. Now, if you measured it, and I said, how many centimeters is this, and you took a ruler and you measured the centimeters, then you have to use significant figures because you've taken a measurement and used some sort of instrumentation, not just a definition. Like if you took the equation for the radius of a circle, you know that's half the diameter, right? Now, if you measure the radius, if you're calculating the radius and you measure the diameter, then you'll have significant figures associated with that measurement. However, when you use this 2, realize it's a perfect number. It's 2.0 to infinity. Okay? It's going to have an unlimited amount of significant figures. So why does all this even matter? Because there's specific math that you're going to have to do. And I'll show you how that works. Okay, first of all, let's see. Don't look. Don't cheat. Okay, see if you can answer these. How many sig figs are here? 2. Why don't I count those zeros? They're holding place, right? 1.080, how many? 4. I count this 0. Why do I count that 0? It narrows our window of uncertainty, right? But you're right. That's exactly what it does, and that's why it works. It makes our answer more precise. It makes it more certain. 2371, how many? 4. Why does this 0 count on 1.080? Why do we count that one? Because it's in between, right? All right, 2.97 times 10 to the 5th. How many is there? There's 3. Don't worry about this part of it. Remember, this is just tells you a factoring, like what to multiply it all by. Ignore this. This is actually a perfect number because it's just 10 to the 5th. Okay, you're looking over here, just at this part. So there's 3. 1 dozen equals 12. It's a perfect number, right? It's a definition, so it's unlimited in that amount of sig figs. What about 100,000? How would I classify that? It would be ambiguous, that's right. But if you had to pick, based upon how it was written, how many would you pick? 1. Okay, just 1. That's why you should avoid it at all costs. Okay, write it in scientific notation. Good. Piece of cake. Have you guys learned sig figs in like MLT or something?